So welcome to this presentation. I am Francois Dion, and since he already introduced me, I won't bore you with a lot of details. However, what I'll say is if you go to slides.com/FDION, you'll be able to access this presentation, and one good reason to do that is throughout the whole presentation I have links to different websites, different modules, packages, applications, and you'll be able also to access my GitHub repo. On the GitHub repo, I have some of the open source software that I've written, namely STEM Graphic is an EDA platform that started initially as kind of an exercise to implement stem and leaf plots that John Tukey introduced in the 70s. And next thing you know, I have a full-fledged EDA application that I've built. And I also build commercial applications such as Visuai, as he mentioned, a data quality platform. And it does anomaly detection, and in the case of data that you feed it, it recognizes if there's geospatial data. For example, maybe you have IP addresses and it's a log of attempts to hack onto your website. Well, it would represent that as by default as a data map overlaid the IP addresses, a location, along with the circle basically representing just how precise this information is. This is an actual extract from September 1st on one specific website that I manage. And there were 154 actual heavy attacks on that website, and I was able to track down the bulk were out of the United States, so they were not as much of an issue because automatically they were being blocked for that application. So that's enough about me. How about you? Briefly, show of hands, if you're familiar with data science in general, at least from the term, yes, okay, a few. Have you heard of the Python programming language? Okay, well, how about R programming language? Also, same individuals. You probably know then the Jupyter Notebook. Yes, a few. All right, so we'll talk a little bit about that and other things. And as was mentioned, this is based on the Hitchhiker's Guide to the Open Source Data Science Galaxy brochure. There's a link again, so if you access the presentation, and I'll have the link at the end also again. You'll be able to download it. And in this brochure, there were two things that I highlighted. One was that data science is about a question and an answer. And John Tukey, again, had the vision, that was back in the 60s, far better an approximate answer to the right question than an exact answer to the wrong question. I mean, what good is answering the wrong question? No good at all, right? And so in that brochure, I also add this data science wheel. And so just as Katie mentioned in her presentation how cartographers are being asked to do more and more, data scientists also have to deal with, first of all, good communication, because the question and answer is part of the communication process. You have to have domain knowledge. If you're looking at predicting floods and you know nothing about that, then that's not going to be very good, the results that you'll produce, obviously. And so you'll then have to leverage data, models, technology, code, and visualization to provide a solution, possibly, or at least get to the point where you can answer that question. And so, for example, also I am really in favor of as many visualization as we can for communication, because you can say a lot in one picture that would require a lot of text to explain, or many tables that people maybe won't connect with. And so that was one of the choropleth that was in the brochure. And but really, that brochure didn't cover a lot. I think I covered 3 packages that were tied to cartography, and maybe I had 2 maps over 16 of the visualizations that were in the brochure. So with that in mind, So data science, sometimes we're asked to build models. And now why would we have a street road? You know, it happens. So because reality is stranger than bad data. And so when we're building a model and we're like, oh, it's going to be super simple for figuring out the street names, I'm just going to remove any qualifiers like road and street, and oh, wait, now I have nothing as a road name or a street name. Okay, so again, so visualization of the data, you have to know the overall picture and also the fine detail before you can start modeling something, right? And so there are many applications that are available. Oh yes, I almost forgot. Again, another link, again, because I think visualization is so important, if you follow this link, you'll find my series of Ex Libris of a data scientist. And the part 5 is on visualization, and there are many books ranging from some that you might not know about. Well, that was that. Graphic presentation from 1939, and it goes back, the books goes back all the way to even the census from 1900 as a source of inspiration for visualization. This one was in color, graphic presentation by Brinton, and it's a private printing, which was pretty amazing that he did that in color. And then another one that's on that list is Sémiologie graphique from Jacques Bertin. So I'm sure most of you are familiar with Bertin's work for maps, but he did a lot for visualization in general. And that was from 1967 in French, but it's also available in English as Semiology of Graphics. So applications, most people are familiar with QGIS, maybe Blender, and there's some plugins. Jupyter Notebook is really the application that I spend most of my time in for data science applications. And as far as on the database side, Postgres is the go-to usually because it scales fairly well. Of course, you have PostGIS extensions, Crankshaft. If you want to load OpenStreetMap data, you can use Impossum. So there's a lot of open source tools that are out there, and basically just figure out what's the most comfortable for you. So at the beginning of the journey, so you have this database full of data, you're like, yay, now I can start building models. No, wait a second, it's on your database server. It's not yet available for you to manipulate. You gotta have the right format. So I'm going to mostly focus on Python tools here. Some of the Python modules that are available for this, you have SQL Alchemy. SQL Alchemy is an abstraction layer, and then you can use specific drivers for the database that you're using, in this case PsychoPG2 for Postgres, and GeoAlchemy 2 for GIS extensions. GDAL, OGR, most people should be familiar with those, but there's a Python version for that. It supports over 200 different file formats. So now we have the data, and we load it into memory, typically in a pandas data frame. Anybody familiar with pandas data frame? A few. So think of it as an Excel spreadsheet, except that whereas I make Excel cry on a daily basis by trying to load over a million rows, pandas has no problem handling that. And so when you combine pandas, Fiona, and Shapely, you get GeoPandas, which supports GIS. Within the data frame. So again, a basic building block. Now, if you need to scale beyond what a single machine can handle and you need to work with GeoPandas across multiple servers, there's Dask GeoPandas. And then last year, there was an interesting presentation on CartoFrame, so I won't cover that, but you can definitely go and look on it on YouTube about this platform. Alrighty. So now I got the data. I'm ready to build a model. No, not yet. Why is that? Well, because the data might not be all that I need to build a model. For example, street names. When you're looking at two different streets, you're comparing the textual description of the street. Well, there's nothing the computer can really do about that to figure out how far these two are, right? You got to geolocate them. At the same time, you might actually want, as part of your process, might want to just compare the strings, so that would be a different package. But here, I'm just wanting to geocode them, so I would use GeoPy. It covers 18 different APIs, from Nominatum to Google to, 18, except the US Census geocoding, which is a separate module. And there's a ton, if you're interested in US Census data, there's a ton of Python modules that are available also specifically for that. What about IP addresses? Just as I illustrated with VisuAI earlier, showing the IP addresses of the attackers on a map, IP2Geo tools can code that against 14 different APIs. Projections. So a lot of the tools expect web Mercator projection, which there's some, yes, I see some issues with that. In fact, some governments will not use that for the lack of precision in certain areas. But so with PyProj, you can make modifications. Cartopy extends that. SciPy Spatial, I won't go into the details, but if you needed KD trees, Voronoi, or Minkowski, that's where you'd look. Scikit-image. For example, for raster images, let's say you have drone imagery of farmland and you want to have like edge detection and build vectors out of that, so you could use a scikit-image to do that. So now we're ready to build models. Everything is related to everything else, but near things are more related than distant things. So when we think about distance, in machine learning for Python, scikit-learn has both a module for clustering and one for distance. And these can interoperate, so if I'm using Haversine instead of Euclidean, that'll work, it'll know about it. If I'm wanting to do a distance between strings for the duplication of data, then I would look at Levenshtein and so on and so forth. For graphs, NetworkX. And if I combine graphs with OpenStreetMap, there's a package called OSMNX. And let's see if I can briefly get into the little demo here. So again, this is a notebook, but I'm using the presentation mode out of the notebook. And after importing the module, we'll use Norfolk, get graph from place, so one line of code basically gives me an object that I can plot. And I could zoom in on it, but I'm in presentation mode right now, so I won't be able to. Then I could actually do a projection, verify that I'm using WGS84. I can do operations like convex hull to figure out the bounding of this object and get the area, for example, in meters. There. And basic stats. And extra advanced stats also are available directly through that package. And then let's say that we wanted to know the shortest path from the hotel to the Virginia Zoological Park. The shortest path is 3.6 kilometers. And we can, again, plot this. So again, it's a good integration of all the different modules in the Python ecosystem that makes things relatively straightforward. Now, if that was not enough and you need to go into deep learning, there's PyTorch and many others. Or if you need to use the R packages from Python, you can use RPY2. And lastly, visualization. So you have the more simpler packages on the right. Matplotlib is the base plotting package, and then you have a leaflet, for example, and an example of leaflet would bring you an interactive map that you can interact with. And that was when I was tracking Hurricane Florence, which ended up dumping about 7 inches in Winston-Salem, which was not bad, whereas Michael dropped a lot more. So, but anyway, so you can easily build these maps with the basic tools here. And then 3 ecosystems, Altair, PyViz, and Dash. Altair is a relatively newcomer. PyViz is a collection of tools that have been around for a little while, and great support for earth sciences, data shader, which allows to scale into the billions of points, and finally Dash to build individual dashboards or full-fledged web applications also. And there's many more, and we wouldn't have time to cover them, but that's basically it, and I think we have just a little bit of time left for some questions. And again, that's to access the slides right here. Thanks.
We're at the break, so we will take questions. Anyone? Okay. All right. Thank you, Dion. That was great.